Right. So we had started working with DAOs. We introduced the notion of breaking up, of modularizing the data access into a dedicated set of DAOs, or data access objects. Right. That it's a bad practice to, that's a good practice to encapsulate all the data access into just a few dedicated classes that that deal with everything that has to do with interacting with the database, right? And we had created several of these access, several CRUD operations that allowed us to create a website, find all websites, or update a website, and we had implemented several of these functions down here: update website, finding all the websites, creating a website, and whatnot, right? And we did this last week. We tried it out and tested it using a driver here, main down here, and also we exercised it using a Java server page to access it from a server side page. Yes, okay. So let's revisit some of this. I have a couple of slides that I have documented the process, right, of creating a simple JDBC, creating a DAO, and connecting to a simple database, and doing some, loading the driver, querying it. So this is what we did last week, right? Getting a record. And then after you access the database, just close all the resources behind you. Yes. So let's continue. Did we talk about prepared statements? I believe so, right? We said that to avoid a SQL injection, that it was preferable to use prepared statements instead of just using simple statements. I don't believe, did we work on departments, employees, and whatnot? We didn't do that, did we? Yeah, let's stick to the assignment. Yeah, websites and whatnot, right? So this, anyway, employees and departments, that's boring. But the DAO, right? This is I documented creating a DAO, which I believe we did, a base DAO. Right, we did create a base DAO. Yeah, there it is, where we're storing all the information about the common things about all DAOs. Then we created several DAOs that extended the base DAO, right? That implemented several of the CRUD operations. So this just goes through implementing several of these updates. So I'm not going to do that. What I am going to do is I'm going to improve on the data access object so that instead of being used as a instance, right? Like we're doing, that we're instantiate every time we need a DAO, we just instantiate it whenever we need it. Instead, a better practice is to use it as a singleton, right? That there's only ever one instance of these objects, right, in the entire system, right? As opposed to every time that I need one, I would reinstantiate, right? Instead, the DAO would be able to maintain an instance of itself and then just give it to us whenever we require it, right? And inside of the object, we could cache all sorts of things. We could cache connections. We could cache all sorts of things so that we don't have to recreate them, right? So I'm going to re-implement this so that instead of these DAOs being used as new instances like this, right? Let's implement this so they are singletons. There's only one of these around. Right? So to do that, what we're going to do is that we're going to internally declare a private instance so that it can be accessed only from internally of the class. Right. So ours is website DAO. So we'll declare a private static website DAO, and here's the DAO. This is the one instance. There's only ever want to be one of these, right? And that is going to be the instance, right? The other change that we're gonna make is that we're going to make the constructor. Right? Notice that we're not doing anything with the constructor here, right? So we're using just a plain old default constructor. So that's how we're instantiating it right here, right? Using the default constructor. So instead of using the default constructor, we're going to make the default constructor unavailable, right? Nobody can ever use that constructor because we don't want anybody making a new instance of us, right? We want to manage our lifecycle ourselves, right? Again, it's a very common practice. We're going to make the private. We're going to make the constructor a website DAO constructor private. Right, so now notice that since main is inside, right? It can still access it. Oh, can I make this? Let me stop this server for a second. Okay, but we don't want anybody outside to be able to use it. So if website DAO now is private, anybody who's trying to instantiate this from outside our class, right, it's going to get an error. Right? So instead, what they should do instead is to use a function that returns an instance of this website DAO, right? Get instance. That is going to be responsible for managing our lifecycle. Right? If we already have an instance, if the instance that we have that it's over here, let me copy it down here. Let me keep it all at the bottom. Right? If it's null, we're going to check to see if the current instance is null. Then we're just going to instantiate it brand new. We'll say instance new website DAO. Right? If it's not null, meaning it has already been instantiated, right? So let's deliberately instantiate it. We're just going to return the instance. Right, so now we're guaranteeing that nobody can get a hold of us, right? Unless we're handling that access, right? So now this access of website DAO, it would not be by instantiation, but it would be through the use of that static method, right? Get instance. Yes? Right. So now we would have to go back and change wherever we're using this website DAO. We would have to rewrite it. We have to refactor it so that it uses this new way of interacting with the instance, right? So for instance, maybe the GSP now. Notice that it gives me an error. See that? It highlights it saying that constructor is no longer available. Okay? So we need to refactor it and say, well, yes, I know it's not available, so instead you're going to get an instance. You use get instance instead. Oh, well, this needs to be public. Yeah, the get instance needs to be public. Otherwise, nobody can ever use it from outside here. So there we go. All right, so go away. Yes, no, yes. It still hasn't compiled. Get, there we go. All right, so this should still work identical to before. If we run this, it should still get a hold of it. Where are you? Is this it? Maybe? Is this it? I guess so. Yeah. There we go. And we should be able to access it from outside as well. Is it working? Yes. Okay, that's a little better. Everybody okay? All right. All right. The problem with this is that it's breaking. Right. It's breaking the architecture. Right. The architecture presumably has the front end. Right. This JSP here is our view in the MVC design pattern. It's accessing the data directly. Right. So it's breaking the design pattern, right? It's instead, according to the model view controller design pattern, there should be a middle tier in between there, right? That is responsible for interacting with the user, interacting with all the events that the user generates, right? and it should be the controller responsibility to go and fetch the data to provide to the view, right? And so let's refactor this to use that design pattern. So this design pattern, the model view controller, has been around for quite a while and has been proven very useful over and over. And the idea of the model view controller is to try to deal with the complexity of large applications, right? If your application is a very simple application, maybe model view controller is an overkill, right? But with larger applications, enterprise applications, usually these are very chaotic. They have multiple teams, and so as humans, we like to break up things, right? And so that we can deal with them and divvy them up, and so that multiple teams can work together, right? So model view control is one of those design patterns that allows us to think about the application as an overall architecture, right? Define these three buckets, right? And the model, the view, the controller, and deal with the different concerns, right? Dealing with implementing the view has completely different concerns of dealing with storing this in the database, right? They have to work together, but they deal with different issues. The view needs to look pretty, needs to interact with humans, that work at very low bandwidth, right? They type, right? They take forever to provide data. Whereas the server can run at lightning speed and deal with thousands of users simultaneously, right? So it's a completely different concerns, right? Different throughput, different bandwidth, different. Right. Whereas on the server, the database, you have to think about multiple transactions going at the same time, multiple threads running at the same time, and making sure that data is not overwriting each other. On the client side, you just have this user interface looking pretty for this one user, right? That is taking forever to type their username and their password, right? While thousands of other things are happening simultaneously on the server. So completely different concerns, and they should be treated. And each one of those concerns typically has different skill sets, right? So typically you might have engineers that spend their entire career only doing front-end development, and engineers, their entire career just doing server-side development. Okay, it's very common. Although today we see that it's becoming more and more common. The full-tier engineer that feels comfortable at all layers of the application. Yes, that's becoming more and more common. So anyway, so let's break it up so that we stay in the multi-tiered MVC architecture. All right, so let's do that.